The first accurate estimate of the distance around Earth was done by the Greek astronomer Eratosthenes, who lived from 276 to 195 BC, who noted that the noontime position of the sun at the summer solstice in the city of Syene differed by 7 degrees 12 minutes from its noontime position in the city of Alexandria. The distance between these two cities is 496 miles. Use the arc length formula to estimate the radius of the Earth, then find the circumference of the Earth. So yeah, these latitude and longitude type measurements are interesting when you consider the application of arc length, which is easy to calculate if you're working with angles in radians. So they give a description here, and they're showing Syene like straight up and down, but the way I imagine it is, so the longitudinal circles are all the same size, unlike the latitude circles. So you don't have to be like at the North Pole. These two cities could be here and here, and the distance between the two cities, which is, it's not a straight line distance, it's like an arc length distance with respect to the globe, and you just measure the summer solstice. You know that the sun's at the same position in the sky, and so you measure the angle difference. You get an angle with respect to something in this city of the sun, get that same angle on the summer solstice in this city, and then you see the difference between those two angles. Okay, and again, when you're thinking about longitudes, you think of the Earth as a sphere, and the equator has a certain radius and circumference, but all of the longitudinal circles have that same radius or circumference. It's only the latitude circles that size changes. So if you could get the radius and circumference of a longitudinal circle, and then you're looking at the Earth as a sphere. So okay, but they kind of represent it with like Syene straight up and down, almost like it's at the North Pole or something. I guess you could still do that, but so you can see the difference in angle between the two. The angle of the sun measured in Syene at the summer solstice compared to the angle of the sun measured in Alexandria, the difference is 7 degrees 12 minutes. Now, they indicate the shadow here. I'm not sure why they do that. The shadow doesn't end up coming into play in this problem. But okay, with that angular difference, how could you estimate the radius and circumference of Earth? Circumference being the distance around the entire globe. Well, the key is you have this angle, but then the other big key is that you have the distance, the arc length distance that angle corresponds to, because you know the distance between the cities. That's the key. So let's convert 7 degrees 12 minutes to radians, because radians are easy to work with arc length when it comes to arc length. So what is 12 minutes in degrees? There's 60 minutes per degree. So 60 divided by 12 is 5. So this is 1/5 of a degree. Okay, so 7 1/5 of a degree is 7 times 5 is 35. So 36/5 degrees. So 36/5 degrees times the fact that you've got pi radians for every 180 degrees. So 36 times pi divided by 5 divided by 180 is pi over 25. Okay, so let's go ahead and get the radius of the Earth first, the estimated radius. So if in radians, S is equal to theta R. That's it. It's a simple formula. So the radius then is, if we have S is 496, and we've got theta in radians, so there it is. So 496 divided by So about, we'll say 3,950 miles. Okay, now what about the circumference? Well, it's 2 pi r. There's different ways we could do this. I mean, you have like a conversion factor here between angle and arc length. We know that for every 7 degrees, 12 minutes, or no, for every pi over 25 radians, that corresponds to 496 miles of arc length. So we could convert that to, okay, what is that? So then what length, arc length is 2 pi radians, right? You see what I mean? So we know that there's 496 miles for every pi over 25 radians. So what would a full rotation correspond to? And now we're in miles, and that would give us the answer. Or we could say 2 pi r. So 2 pi times r. 2 times, that's circumference, pi times r, 24,800, or, okay, 496 times 2 times pi divided by pi over 25. See, get the same answer either way. So about 24,000, the circumference, 24,800 miles.